The Pythagorean identity, special angles in the unit circle. Now, we've already talked about the Pythagorean theorem. A squared plus b squared is c squared, where c is the hypotenuse opposite of a right triangle. Now, we've also talked about the unit circle. We're utilizing the central angle from the circle. We can find any position on the circle. And if you look at this here, off to the right, remember we studied cosines, which is, and sines. The cosine is the adjacent over the hypotenuse. The sine is the opposite of our hypotenuse. I want to combine the circle here with the hypotenuse of a right triangle. And what I have here is a circle of radius 1. From here to here is 1, or from here to here is 1, or from here to here is 1, or here to here is 1. Let's erase that, otherwise it's going to get messy real fast. But anywhere from the center of that circle to the edge of that circle is going to have a radius of 1. Now what's interesting is if I go from the center to one point here, again, that is a distance of 1. I drop a line straight down. What do I have here? I can drop a line going across. I have a right triangle. Because a right triangle is defined as having a triangle with one right angle. And anytime one line is perpendicular to the other, this is my x-axis, going this way and this way. And this is my y-axis going this way and this way. We always know the x-axis and y-axis are at right angles to each other. So I have a right angle there. And since I've enclosed this from the circle from here to here, you can close this and make it a triangle. It's a right triangle. And here's the angle right here. If I look at this angle right here, it's theta. We always call the angle theta. That's Latin. When you start, it's a Greek letter. This side is the sine. It's the opposite. And here's hypotenuse. So I can figure out the angle of this in this circle opposite over hypotenuse, because I know I got a right angle here, and it's a right triangle. In fact, I can also do the same thing with the cosine. Remember, here's the angle. The cosine is the adjacent, and the adjacent along the x-axis. So I can find the angle here with the cosine, which is adjacent over hypotenuse. And here's what's really interesting here. The cosine of it's got a hypotenuse of 1. Whatever the cosine is the x-coordinate right here. Whatever this distance for the sine is, the distance right here, is the y-coordinate. So basically, when you look at this circle here, the xy coordinate circled here is cosine of theta, and this is my theta, my angle here, and sine of theta. We can do a lot since we've developed this. And this is, since it has a circle with a radius of 1, we call it the unit circle. We can do a lot with that. With the unit circle of 1, as I said, the cosine is the x-coordinate. The y-coordinate is the sine. So if I have x and y, I know I have my cosine and my sine. And what's interesting also is we can substitute this. The a equals the sine. The a equals the cosine, b equals sine, c equals 1. A squared plus b squared equals c squared. That's Pythagorean theorem. And since the a is the cosine, the b is the sine, cosine squared plus sine squared equals 1 squared. This is the Pythagorean identity. It's no different than a squared is b squared is c squared. And since the cosine is the x-axis and the sine is the y-axis of this right triangle with a hypotenuse, and this being 1, so cosine squared plus sine squared will equal 1 squared. Now we can do a lot of interesting things with that knowledge. Now, remember I said I got cosine squared plus sine squared equals 1. That's just the Pythagorean identity. If I know the distance from the center of this circle to this point is half, in fact, halfway from here to the unit circle of 1, I can figure out what the y distance is here. Also figure out what which is the same as the sine. Because remember, cosine squared sine squared equals 1. So if I have 1/2 squared, I squared it right here, if that's my distance, plus sine squared will equal 1. Let's erase this here so it doesn't get too messy. Well, 1/2 squared is 1/4. And 1/4 plus sine squared equals 1. I'm going to subtract 1/4 from both sides, do some basic algebra here. And I'm left with 1/4 minus 1/4 plus sine squared equals 1 minus 1/4. So sine squared equals 3/4. And I want to get down to sine. Square root of sine squared is sine. Square root of 3/4 is the same as square root of 3/4. Square root of 4. And that's the same as square root of 4 is 2. So that's square root of 3/2. So if I know this is 1/2, I know this is going to be the square root 3/2, which I got from the Pythagorean identity. There are special angles within the unit circle we often talk about. Now we did 1/2 and square root of 3/2. If I put my calculator in here for the sine inverse, that's 60 degrees. So 1/2 square root of 3/2 is the equivalent of 60 degrees right here. And when I look at this, I can do the same thing with cosine, adjacent over hypotenuse. Cosine, let's see, adjacent is 1/2 over 1, which is still just 1/2, which is 0.5. I do the inverse cosine of 0.5, I still get 60 degrees. And if I know this is 60 degrees right here, I know this is 30 degrees. Pythagorean identity and the special 30-60-90 triangle are the same thing. We can use these in terms of ratios. Remember, these are what we consider similar triangles. They may have different distances, but the ratios are made similar, which is the whole point of trigonometry. If we know it's a right triangle and we know the distance of one, that's the same ratio, because we have the same angles, we can figure out what the other distance is. In other words, if I have the unit circle of 1 here, and it's a 30-60 right triangle, and this is 1/2, then I know if this is 2, this is square root of 3, because square root of 3/2 times 2 is square root of 3, and 1/2 times 2 is 2. Now, 36, we talked about the 60 degrees. We can do the same thing. If I go square root of 3/2 right here, or make it actually even easier to calculate, we're going to go use the Pythagorean identity with this 1/2. That's much easier to see in a circle here. So halfway across, we'll see what this distance is. This is halfway from here to here. And remember, sine is the opposite of this angle. So that'd be 1/2 over the hypotenuse, which is 1. 1/2 over 1 is 1/2, which is 0.5. Cosine is adjacent over hypotenuse. And when we look at this, let me finish the sine first. I apologize. Sine of -1 is 0.5. When I do the inverse of sine -1, 0.5, it's 30 degrees. And we've just really flipped it from the previous one. That's all we were done. And I could test this again, as I was trying to do ahead of time a moment ago. Cosine adjacent over hypotenuse. Well, we already know adjacent is 1/2 over 1. This is 1/2 distance here. And then over 1 is 1/2 cosine is negative 0.866, which is, again, 30 degrees. So we've already figured out our 60 degrees, which is square root of 3 over 2, 1/2 coordinate, square root of 3 over 2. And we figured out our the reverse here, the 30 degrees. Let's look at one other special angle, the 45, 45, 90. Well, it's interesting. I can figure this out without knowing distance if it's on the unit circle. Because 45, 45, 90, I know if it's 45 here and 45 here, then this leg right here, we'll give it 2 slashes here, is going to this leg right here, which means they're the same distance, which really is saying x squared plus y squared equals 1, cosine squared plus sine squared equals 1, or it's really saying 2 sine squared, because if it's equivalent and the cosine is the x-axis and the sine is the y-axis and the distance specifically, cosine is equal to sine at this point. So I'm just going to replace cosine squared with sine squared. So sine x squared plus sine x squared equals 1. That's 2 sine x squared. And I'm just going to divide both sides by 2. And that crosses off. I'm left with sine x squared equals 1/2. And I'm going to get the square root of that because I want to find out what it is for x. Sine x squared equals square root of 1/2. And I'm going to erase this. I'm getting ink all over the place here. And if I look at this here, I got sine, square root of sine of x squared is sine of x. That's equals the square root of 1/2, which is square root of 1 over square root of 2. If I want to simplify it, since I don't like roots in my denominator, I'll just multiply it by 1, which in this case, square root of 2 over square root of 2. Square root of 1 times square root of 2 is square root of 2. Square root of 2 times square root of 2 is square root of 4 or 2. So this is square root of 2 over 2. And square root of 2 over 2 is going to be my sine. Remember, I said my cosine is the same as my sine in this case. So the actual distance is, and I can put in what that is, square root of 2 over 2. I divide my calculator, 0.7071. The inverse of sine is that, 0.7071 is 45 degrees. The inverse of the cosine of that is also 45 degrees. So it is the square root of 2 over 2 times square root of 2 over 2 for that location, and that's at 45 degrees. Now, we've already figured out our special angles here. We've got for 60 degrees, the coordinate is 1/2 square root of 3 over 2 on the unit circle. Square root of 3 over 2 over 1/2 for 30 degrees, and 45 degrees, square root of 2 over 2, square root of 2 over 2. I've got a table here, and notice these are the coordinates. Here is 1, 0, that's where it starts. Square root of 3 over 2, that's 30 degrees. Square root of 3 over 2, 1/2 is 30 degrees. Square root of 2 over 2, square root of 2 over 2, that's 45 degrees. We've done that one also. 1/2 square root of 3 over 2 is 60 degrees. And if we go from here, from the 0, 1, or 1, 0 to 0, 1, that is a 90-degree angle right there. But notice I've got a third column here, and that is in terms of radians. And let me refresh your memory what a radian is. A radian is the distance around a circle in pies. If this is the unit circle, I know the circumference equals 2 pi r. 2 times pi times radius. And if the radius equals 1, then my entire distance around there is simply 2 pi, because 2 times pi times 1, which is the r here, is 2 pi. Which means if this is 2 pi all the way around, halfway around is 1 pi. And if this is 0 to 1 pi halfway around, and this is pi over 2. This is 3 pi over 2. And then we can start subdividing it. If this is pi over 2 from 0 degrees, 90 degrees, halfway around there is pi over 4. So square root of 2 over 2, comma, square root of 2 over 2 for the xy coordinates is the same as 45 degrees, which is the same as pi over 4. And if I took 30 degrees, and I'm going to erase some of this right now again. If I took 30 degrees, right, sorry. If I took 30 degrees and halfway around the circle is 180 degrees, right? Because 360 all the way around. That's 1/6. 30 out of 180 is 1/6. So it's 1/6 pi right here. 1/6 of a pi, or pi over 6. We already said this is square root of 2 over 2, square root of 2 over 2, or by degrees is pi over 4, because a quarter of the way is pi over 2. And if this is 60 degrees, 60 times 3 is 180, so this is pi over 3. And as I said before, 90 degrees is halfway between 0 and pi, so it'd be pi over 2. Now, if you notice something here, I want to show you something very interesting. Look at the coordinates. I've got, this is my first quadrant. Quadrant 1 is from 0 to 90 degrees, right here. Look at the xy coordinates in quadrant 2. This is still going to be on this side. The y coordinate at this right here is still the same distance as over here. It's still square root of 3 over 2. But I've moved negative 1/2 instead of positive 1/2. It's just the x that has the opposite sign. Same here. Square root of 2 over 2, square root of 2 over 2 is now negative square root of 2 over 2, comma, square root of 2 over 2. And this last one here, with 30 degrees, square root of 3 over 2, 1/2, is negative square root of 3 over 2, 1/2. And I've got my coordinates now, and I know I can divide them up. I know this is 45 degrees, halfway between here, and then I go 45 degrees here. This is 90 plus 45 from half for a quarter of the way, actually a quarter of the way across to this halfway between this. 135. 90 plus 45 is 135. I know this is, if this is 30 degrees, 60 to 90, then this is 30 degrees here. So it'd be 90 plus 60 is 120. And then I know from here to here, halfway across is 180 degrees. It's a flat line back, actually, from the very beginning to halfway. And this is, we already said this is 30 degrees right here. So this is 180 minus 30, which is 150 degrees. And we can do the same things with the pi's here as well. If I know this is pi over 4, and pi over 2 is a quarter way around, here's 45 degrees. I've gone a quarter, I go a quarter way around. Pi over 4 plus pi over 2, which is 2 pi over 4, plus pi over 4 equals 3 pi over 4. 3, I'm terrible writing here, I apologize. Which is what I get here. And I know here this is pi over 2 plus whatever 1/6 is, pi over 6. Well, that's 3 pi over 6 plus pi over 6. That's 4 pi over 6, which is 2 pi over 3. And I know from here to here, if pi, I'm going to subtract pi over 6. That gives me 5 pi over 6. So you can see we're just building up here. Each one is almost equivalent of the other. We are just changing signs, or we're adding angles. But there's a consistency in this, and there's a pattern clearly. Now, when I look at the unit circle here going halfway across, look at this here. These right here, I got 1/2 square root of 3 over 2 for 60 degrees. I go to 180, 60 plus 180 is 240. Right here, it's literally a straight line across. It's now negative 1/2, negative square root of 3 over 2. It is all the same here, except the signs are opposite from here to here, from here to here, and I've gone from 210 minus 180 is 30, 225 minus 180 is 45, 240 minus 180, and 180 is a straight line, is 60. And then I keep adding the pi's right here. If this is 1/6 the pi, let me erase this again here. If I go from here to here, there's pi, and I know this piece is 1/6, so this is pi, or 6 pi over 6 plus pi over 6. Each of this little chunk right here is 7 pi over 6. Here is, this could be 4 pi over 4 right here, which is this pi, plus this is 1/4 pi, 45 degrees. So that's 5 pi. 1/4 pi plus 4 pi over 4 is 5 pi over 4. And I know this is right here. This goes from here to here, pi over 3. If I go 3 pi over 3 plus 4 pi, I'm sorry, pi over 3, 3 pi over 3 plus pi over 3. Yep, I was right. It's 4 pi over 3. This is 3 pi is the same as 3 pi over 3. I'm just making it easier to add this part up. So 3 pi over 3 plus pi over 3 is 4 pi over 3. Finally, I'm going almost all the way around the circle here. And you can see we've got the same thing here as we had in Unit 2, except the signs change along the y-axis. The x's are the same, as you can see. Here and horizontal. Oops, right there I'm at. The only thing that's the opposite is the cosine. Yeah, the cosine's the same. The signs have the opposite sign now. Instead of square root of 3 over 2, I got negative square root of 3 over 2. Instead of square root of 2 over 2, I got negative square root of 2 over 2. But it's the same concept. If you can learn one component, one quadrant, you can figure out all of them. Because again, all I'm doing is adding the angles as well. And I'm also right here, I know it's 30 degrees. If this is 270, 3/4 of the way around, 1/8 plus 90 is 270, plus 30, it's 300. 270 plus 45 is 315. And then this is 60 from here to here. 270 plus 60 is 330. And then we go back to 360 or 0, which is considered 2 pi or 0 pi. And then I've done the same thing with actually looking at the radians as well. I know this is 3 pi over 2 plus pi over 4. That's 6 pi over 4. 3 pi over 2 is 6 pi over 4 plus pi over 4, which gives me halfway between those two marks, 7 pi over 4. 3 pi over 2, let's say I got this, I know this is pi over 6. If I've 3 pi over 2 is, if I want to get to 6, I multiply both sides of 3. So that would be 9 pi over 6. 9 pi, it's terrible here, I'm sorry, over 6, plus pi over 6, which is 10 pi over 6, or 5 pi over 3. So if you can learn, basically, we can figure out how to get this angle, this angle, this angle. The coordinates we've already done with the Pythagorean identity. And then we know a pi all the way around, 2 pi, halfway around is pi. We don't have to memorize the unit circle. You can actually easily determine it out once you realize your Pythagorean identity on those angles. And that's all you have to learn, is these three right there.